Think of yourself as a passenger in a rocket that has partly exited the atmosphere of Earth. To enjoy the scenery while traveling to Mars, you take off your spacesuit helmet, take a deep breath, and watch a moss-covered asteroid pass by when all of a sudden, there is a peculiar noise. However, there is no need to be alarmed, it was only a supernova explosion in a neighboring galaxy or space. Will we be able to survive in a world with air in space to fill? For example, the solar system will need a lot of air. At the same time, our system will become 6 billion times heavier than the Sun, and that's even more than the mass of Sagittarius? I feel like that's what space would look like if air appeared in it, or not. The consequences might be completely different. We will undoubtedly suffer as a result of a star and the supermassive black hole in the galaxy's core, but let's take a moment to ignore the conflict. Consider the optimal version while applying gravity and other physical principles. The Earth's atmosphere is composed of several layers and is diverse. The atmosphere. Stratosphere. If we fill the solar system with a mixture of gases, they won't fill the space uniformly either. The nitrogen and oxygen molecules that make up the air will be distributed according to gravity. For example, near Jupiter the air layers will be very dense. As a result, the pressure near the gas giant surface will be the same as at the bottom of the Mariana Trench. The thinner the air is, the further away you are from Earth, and if we fill the solar system with a mixture of gases, they won't fill the. In addition to being able to survive for decades without water, these tiny low-speed invertebrates can withstand extreme temperatures of -270 to +150 degrees Celsius. A study from 2007 also revealed that tardigrades can survive even in space's vacuum. However, bracken wasps can also withstand extreme conditions in Jupiter's radiation belts, where radioactive radiation disables spacecraft components. A similar species might appear on Jupiter's surface under the influence of radiation. These processes would take place not only on Jupiter. With the emergence of air, new species would evolve in space, for example on asteroids if there is ATM. The deepest living fish known is the Abyssobrachula galathei, which can even live at the bottom of the Mariana Trench at a depth of 11,000 meters. This mouse can survive without oxygen for 30 minutes as seen from Earth, therefore the asteroid. If a mole rat engages in a rare battle in the air zone, it will manage to live. The double tail will help rodents navigate in space better in a low-gravity environment, but not only small species will be able to survive on the asteroid. The herbivorous spaceyak can reach the same size as the wild yak on Earth, up to 2 meters in height, and their weight range. Furthermore, this animal doesn't feel pain or cold and never comes to the surface. That way it'll be able to protect itself from solar radiation and survive temperature fluctuations. These animals' lungs and hearts grow to enormous sizes, allowing terrestrial yaks to survive in the rarefied mountain air at a height of 5 kilometers. This will also give space yaks an advantage because the atmosphere on asteroids is not as dense as that on Earth, and an additional pair of legs will help keep them stable even in low gravity. Since animals could survive in space, comfortable conditions for humans could also develop there, and now you know. The average density of the universe is 0.3 of a proton per cubic centimeter, but the solar system's space density is much higher, reaching 9 protons per cubic centimeter, and the inner Sorbe's matter density is 10 quadrillion times higher. If we were to change these values, even slightly, the results would be disastrous. For instance, if we inflated the solar system with air to a molecular cloud density, then instead of 9 protons, 1 cubic cent. The first phenomenon we'll see is Jupiter becoming a star. The planet's strong gravity will draw in enough material to transform it from a gas giant into a complete wedge. The fact that Jupiter is almost 3 times as close to Earth as the Sun implies that our planet will experience more heat from a new star, which is terrible news for humanity. We still have a chance of surviving, however, because as the density of the solar system rises, Uranus and Neptune will be able to form a full atmosphere, and as a result of Jupiter's burning, the temperatures on these planets won't be as extremely low. The temperature on Earth could reach Mercury's temperature of 650 degrees Celsius. Fortunately, the conversion of the gas giant into a star will take many years, giving humanity plenty time to prepare for their relocation to Neptune. But what if we raise the density of the whole galaxy, not just the solar system? The Milky Way would get brighter, which would be the first thing we'd notice. The Milky Way will start slowly devouring its neighbors, and the huge and tiny Magellanic Clouds will be the first to suffer. The idea is that the stars will have more fuel and gas giants like our Jupiter may become new suns, but that's not all. Watching the starry sky will be more exciting if we increase the density of our galaxy by just 10 times, it will devour all of its neighbors, and humanity will have to move up to Neptune to survive. But what will happen if the density in space is the same as on Earth for the air density in the solar system? The Milky Way will absorb the Triangulum galaxy and finally Andromeda, but we're unlikely to be affected by the consequences of these mergers. I'm talking about how the gravity of the solar system will draw in new planets as well as meteorites, and who knows, maybe humanity will be able to establish a new home on one of them. From there, we'll be able to observe an amazing phenomenon called the northern lights of the heliosphere, where charged particles from the solar wind collide with nitrogen and oxygen molecules to create new charged particles that first appear as a red-green glow but eventually disappear as the air-filled solar system expands. Sagittarius, if air appears in space, a star will rip us apart and consume us, giving humanity no chance of surviving. However, what would happen to the universe if we felt air in space, not just in our galaxy but throughout the entire expanse? Because air has mass and gravity, under the influence of these forces, the air would compress and collapse, forming huge red-hot clumps of matter, new types of stars over time.